This is question 8.6, part 3, or sorry, part 2. Yeah. All right. So the energy losses in the power station are shown in the following table. Calculate the overall efficiency of the conversion of gravitational potential energy of water in the tank into electricity. Okay, so here's the percentage energy losses: friction of the water pipe, friction in the turbine and AC generator, and electrical heating losses, 5. All you have to do here is you add them all up. Okay, 27 plus 15 plus 5 ends up being 47. Okay, so 47% of the energy is lost. That means that the efficiency is 53%. All right, so here I'll go ahead and write that there. 53%. Okay, sketch a Sankey diagram to represent the conversions in the power station. All right. So this is going to be a real rough sketch, and it's just kind of an estimate, but okay. So 57% of the energy is output. All right. But there's some energy that's gone from the heating loss. This is 5%. All right. This was the 5%, right? Yeah. Yeah, and this is 53%. And these are all in percentages. I'm not going to write the percentages, but they're percentages. Okay, 5. This is heat. Okay. The other one is friction. Okay. Friction is 15%. Okay. And then down here we have turbulence of the water. Okay. And this is that 27%. That says turbulence there, even though it might not look like it. Okay, this is turbulence is just the rapid motion of the water as it's flowing. Okay, it loses energy due to that. Oop. Here, I'm gonna fix these here. There we go. 20, 27. This was 15. Okay, 553. Okay, and that is it. Even though it looks kind of sloppy, it's fine. Okay. Outline how energy is lost in the transmission, or energy losses in transmission are minimized. Okay, so a lot of times you have to transmit the energy over a long distance. What you do is you step up the voltage and you decrease the current, because higher current will cause more resistance in the power lines. And if you step up the voltage, decrease the current, you can send that the energy a long way, the power, because power is equal to voltage times current. And when I send it out, I have the same amount of power, but I increase the voltage and I make the current small. Then when it goes back into the house, I change it back. Okay. So now it has a lower voltage, higher current. Okay. And you get the same amount of power. All right. Use larger cables. They use special cables for the power lines. That's another one. All right. The last question here is about the advantages and disadvantages of pump storage schemes. And one advantage is that you have energy on demand. So when you're producing too much, you just pump it in there. When you need it, you can allow it to flow out. The disadvantage is that you need to have it stored before you're able to use it, and that's the only one that they gave. All right, that is the last question. So see you in the next question that I do.